Hello. So this is going to be our first video for the Chapter 1 study guide. The reason I'm doing this as a video is because with this first week, we're getting set up for sessions. We're figuring out just kind of how to log into my math lab, all that logistics stuff. And then by the time we get that all set up, we're already done with Chapter 1. So I'm going to have just this chapter to watch at your leisure. All the other chapters, I'm not going to make videos like this, just for chapter 1. And it's a good reference because this is the chapter that is the foundation for all of the other material we're going to see. So you can always come back and reference this as we go through each chapter. Okay, so you'll see the chapter 1 data collection study guide. What you should have is the document that's shown on the screen right there in front of you. And we're gonna go through the outline with the putting it together. You can go ahead and read on your own time. It's just basically what is chapter 1 about. You're gonna see 3 little pictures above Princess Leia's head, the Excel logo, Front Range Community College logo, and then the supplemental instruction logo. The reason I put those there is because that way you know what technology we're going to be using for the chapter, because later in the semester we're going to be going and switching to StatCrunch. You know that this is tailored to the Front Range class, and this is supplemental instruction material, meaning nothing on this study guide is for a grade. It's only to help you solidify or understand chapter 1. Okay. So for the outline of what we'll be doing in chapter 1, we're going to be going through chapters 1.1 through 1.6. However, section 1.2 and 1.6 you will not be quizzed on, nor will you have homework on it. It will not be on any exams, but I do go over these because as we go through future chapters, you're going to see a little review section, and sometimes 1.2 and 1.6 come up, so it helps us understand the content of what we're doing, say in chapters 4 and 11, things like that, okay? So we're still going to go over them, but you can just make a note you won't be quizzed, test, or have homework on 1.2 or 1.6. Okay, so let's first start off with section 1.1 where we're going to do some definitions. So the definition of statistics is the science of collection, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. So you're going to see this little symbol pop up, my little head with the light bulb. These are things that are really good to at least have in your mind. So maybe you should put all these into flashcards to just be able to recall them easier, but these are ones that are really important. Okay. A population is the entire group to be studied, while an individual is a person or object that is a member of the population being studied. And then a sample is a subset of the population being studied. So you can think of the population as the whole group. The whole group is made up of individuals. So this could be a person or, like it says, an object, really any noun that fits right there. Okay. And a sample is a subset of that population. So a collection of individuals that doesn't make up the whole population. Okay, so definitions continued. A statistic is a numerical summary of a sample. Now, if you're anything like me as a student, you'd go, what's the difference between A and E? I have statistics, and now E is statistic. So the statistics definition is what letter A is. If I said I have a statistic, that's a numerical summary of a sample. So if I said I have a statistic that the average is 82.7%, that would be from a sample. Okay. Descriptive statistics consists of organizing and summarizing data. They can describe data through numerical summaries, tables, and graphs. So if you've ever seen a pie chart or a bar graph, those are descriptive statistics. Whereas inferential statistics uses methods that take results from a sample, extend it to the population, and measure the reliability of the result. So some examples of inferential statistics that we're going to see is, there's a 25% probability that it'll rain today. So, we took data from a sample with these conditions 25% of the time it has rained. So now we're going to say those conditions are again happening next week. So there's a 25% chance that it'll rain. Parameter is a numerical summary of a population. So if I said the population mean was 62.7%, we could say, okay, that was a parameter. So you see my little light bulb pictures there. So those ones are really important to remember, especially when we're starting probability. We're going to be identifying what's the statistic, what's the parameter. And in the sessions, I'm going to be asking, what's a statistic, what's a parameter? And they're really actually easy to remember because you'll see I bolded the word samples and population. So statistic and sample go together, the two S's, and then parameter and population go together, the two P's. Okay, so what are the 4 steps in the process of statistics? Our first step is going to be identifying the research objective. So what is it that you want to research? What is it that you're wanting to collect data on? The second step is you're going to collect the data needed for that objective. So we're going to talk about how to get the samples, how to accurately reduce bias, so that way they're representative of the population your samples are. Then we're going to describe that data. So what we collected, we're either going to put into tables or graphs, things like that. And then we're going to perform an inference, meaning does this data extend to the population? That's our ultimate goal, is our sample going to accurately reflect the population of interest that we're looking at? Okay, so let's do some more definitions. Chapter 1 is very definition rich, so other chapters will not be. Like I said, it's just the foundation, so just make sure you have good references to look back on when you need to answer questions based on this. So we're going to have something called qualitative variables. I like to call them categorical variables because when I look at the words qualitative and quantitative, for some reason my brain can't distinguish between the two because they're both Q, they're both very similar, but when I see categorical numerical, it makes it a little more easier for me. So categorical data allows for classification of individuals based on some attribute or characteristic. So we could think of categorical variables, something like hair color, or we could think of it as something like favorite movie, right? When we're looking at those variables, they're usually words that are the answers. So whereas quantitative or numerical variables are going to be numbers, so they provide numerical measures of individuals. The value of this variable can be added or subtracted and provide meaningful results. So a quantitative value could be something like your height, your weight, or what was your exam score, okay? Because the data we're collecting is numbers. A discrete variable is a quantitative variable that either has a finite number of possible values or a countable number of possible values. The variable cannot take on every possible value between 2 possible points. In other words, discrete variables are whole numbers. So 2, 7, 20, 100, 1000. Anything that's a whole number, that's a discrete variable. Whereas a continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. In other words, they're measurable. So this variable can take on every possible value between 2 possible points. So we can think of 1.25, 2.5, 1000.75, right? Anything that has those decimals afterwards, we're going to consider continuous variables. Okay, the nominal level of measurement is a variable. A variable is this level of measurement if the values of the variable, name, label, or categorize. In addition, the naming scheme does not allow for the value of the variable to be arranged in a rank or specific order. So when we're looking at our categorical data, nominal would be something like hair color. If we have a standard XY table, right, in our X column, we could have blonde, brown, black, red. Those are the hair colors, right? However, it doesn't matter what order they're in. You could have red first, you could have blonde first, you could have brown first, you could have black first. It doesn't matter, right? Because they're all independent names or categories. Whereas the ordinal level of measurement is a variable is this level of measurement is if it has the properties of the nominal level of measurement. However, the naming scheme allows for the values of the variable to be arranged in a rank or specific order. So you could think of military ranking, you could think of class ranking, so freshman, sophomore, junior, senior, right? In order to be a sophomore, you had to be a freshman first. In order to be a junior, you had to be a sophomore first. So that follows a rank order. Freshman's going to be the lowest of the tier, senior is going to be the highest of the tier. So I give you this little chart in order to organize this information, because I know when I took the class and I was fed this information, I was like, great, it's all scattered in my mind. How do I organize it? So this is the best way to organize that, I think. So you could see these first top two boxes says, what are the two types of variables? Remember, that's categorical and numerical. You can say qualitative and quantitative if that makes sense for you. I provide both just to make this simpler. So we have categorical and numerical variables. Then this says, what are the two subsets of the variables shown? So for qualitative, we have nominal variables. And for qualitative, we also have ordinal variables. So that's how they split up. Qualitative is words. They can either be independent, arranged in any order, so that's nominal, or they can be dependent, arranged in an order, that'd be ordinal. Okay, for our numerical variables, the two subsets of the variables we have are discrete, remember, are the whole numbers, and continuous are the measurable numbers. Okay, so this is in problems A through C. Classify the variables as qualitative or categorical, or quantitative or numerical. If the variable is qualitative, state whether it is nominal or ordinal. If the variable is quantitative, that should say, see, I told you I'm always making mistakes. It should say if the variable is quantitative, state whether it is discrete or continuous. So I have this little blurb here. It says, remember, categorical is names and numerical is numbers. So use that flow chart from number 4 that we did to answer these questions, because these are typical homework questions for chapter 1. Is this categorical or numerical? Okay, is it discrete or continuous? Is it nominal or ordinal? So let's think about this. We have number of y-wings in the hanger on Yavin 4. Well, the word number is a key giveaway, so I know it's not categorical. It's going to be numerical, but can I measure the number of y-wings? I mean, you can argue that, but mainly we're going to keep things simple and say we can just count the number of y-wings in that hanger. So this is going to be numerical, discrete. Okay. The weight of kyber crystal in grams. Well, the output that we're going to get in weight is going to be a number, right? And because we're weighing the weight of that crystal in grams, we're actually measuring that. So that would be the numerical continuous. Okay. Names of Jedi in the Jedi Temple on Coruscant. We can have the names listed in any order. We're not looking at rank here. So this would just be categorical, nominal. And then the Jedi ranking, for example, Padawan, Jedi Knight, Jedi Master, if we're starting at the lowest level and going to the highest level, and we're classifying them by Padawan, Jedi Knight, Jedi Master, that's going to be the categorical ordinal. Okay. So in problems A and B, we're going to determine whether the underlined value is a parameter or a statistic. And as I'm doing this, I realized I didn't underline it. I'm so sorry. So you can go ahead and just, hopefully it's on your study guide underlined. If not, the 73% in letter A is supposed to be underlined, and the 12.5 in letter B is supposed to be underlined. So remember, a parameter is a numerical summary of a population, and a statistic is a numerical summary of a sample. So in a survey of 1,011 Trandoshans aged 50 or older, 73% agreed with the statement, I believe in the Force. This would be considered to be a sample because 1,011 is just a specific number of that species. There's probably way more of that species in the whole galaxy. All right, in 0BBY, which stands for the Battle of Yavin, Rebel pilot and Jedi Luke Skywalker completed the Death Star trench run in 12.5 minutes. This is going to be a parameter. So here's a note you should make. Any measure on an individual is a parameter because that individual makes up 100% of their data. Now, I'm always going to counter this in a respectful way. If you're looking at this and going, oh, that was a trick question, I don't like that term. I'm never trying to trick you. I prefer the term critically thought out question. So I'm trying to give you questions that have you critically think about what it is trying to say. And, you know, as a therapist, right, I'm always having the mind frame of the way we think about something is going to shape our reality, right? So if we think that we're being tricked all the time, we're not going to have a lot of trust in the problems that are given to us. But if you know that I'm coming at this from a good intent of, I want you to critically think about this so you're well prepared, you won't feel tricked. You'll just feel more prepared for the problems that are going to be given to you. Okay. Sorry, just had to go on a little tangent there. All right, so in problems A through D, we're going to determine the level of measurement, in other words, nominal or ordinal, of the qualitative categorical variable examples. So these are all categorical variables. We're just determining if they're nominal or ordinal. So birth planet. Think of this if we collected data. Where were you born? What planet? Right? Are we going to rank these? No. So it's just going to be nominal here. What about your Jedi status? Are you a Padawan, a Jedi Knight, a Jedi Master? Right? We already saw that, so we know that one's going to be ordinal. What about lightsaber color? Someone is blue, another person is green, another person is purple, someone has white. Right? This is going to be nominal. Again, it doesn't follow a rank order. We can just categorize it how it is. And in Star Wars movies, we're going to say ordinal. Why are we going to say ordinal? Because they came out in sequels, right? So this was the first one that came out. This is the second one that came out. This is the third one that came out, and so on. I always shudder to see the articles that say the best Star Wars movies ranked. That'd be considered ordinal data. However, it's opinion, so it's not really factual. Okay, so there's some nominal and ordinal there. So now let's contrast the difference between qualitative and quantitative variables. So qualitative and quantitative differ, as qualitative variables are words and names, and quantitative variables are numbers. Then let's discuss the difference between discrete and continuous variables. Discrete variables are whole numbers, for example, 1, 2, 3, 4, 5, whereas continuous variables are measurable numbers, for example, negative 1.02, 0.33, 45%, and so on. Okay, so that brings us to the end of section 1.1, and you're going to see with numbers 10 and 13, these are open-ended questions. So here's a little blurb I wrote. These are open-ended questions that help you critically think out the chapter section. I want you to answer these on your own, then you can compare and contrast once the answer guide posts. The answer guide is posted along with this video. I'm not going to tell you how best to study. I will give you some advice that the best way to study is just to try this on your own. I know there comes a lot of anxiety about, am I going to get this right? Especially in the summer semester, things are fast-paced, things like that. Do what works best for you. If it works best for you to look at those answers on my answer guide, copy them down, and then meditate on them and really think about it, go ahead and do that, okay? I just think the best way is this. However, the way I think works best for people isn't always what works best for people, okay? So try to answer them on your own and then see how they compare and differ from the study guide. So I also wrote this little blurb. You can do this. Use everything we answered in section 1.1 to help you answer the questions, okay? You just have to kind of critically think what 1.1 was saying to answer those questions. Okay, so for 1.1, you should be able to define statistics and statistical thinking, explain the process of statistics, distinguish between qualitative or categorical variables and quantitative numerical variables, distinguish between discrete and continuous variables, and determine the level of nominal or ordinal measurement on a qualitative categorical variable. Okay, and we'll kind of, at the end of this video, talk more about what to do with these bullet points. So remember 1.2, you are not being tested on, you're not going to have homework on. However, it is important to understand what observational and designed experiments are as we go forward within the semester, okay? Because you might be going, well, why are they doing that? Why can't we say that this study proves that? And I'll go, well, it's because it's an observational study. Oh yeah, I remember we talked about that 1.2, things like that, okay? So we're gonna do some more definitions. Told you this chapter is definition rich, so we just gotta keep going with the flow with it. Observational studies is what measures the value of the response variable without attempting to influence the values of either the explanatory or the response variable. That is, in this study, the researcher observes the behavior of the individuals without trying to influence the outcome of the study. So an observational study example might be, I'm just going to take whatever your homework scores were, and we're just going to compare that each time you do homework, okay? I am not influencing the amount of homework you do. I'm not influencing how you answer those. I'm just recording that data, okay? That'd be an observational study. Whereas in a designed experiment is if a researcher randomly assigns the individual in a study to groups, intentionally manipulates the value of the explanatory variable, controls other explanatory variables as fixed values, and then records the value of the response variable for each individual. It's that specific study. It's a designed experiment. So if I recruit you and I say, okay, you're going to group 1, you're going to group 2, now group 1 gets this, group 2 gets that, here's the results. Okay, I could say this proves group 1 got those results because of what I gave them. I manipulated the whole scenario. Observational, I just observed what happened. Okay, lurking variables is an explanatory variable that was not considered in the study, but that affects the value of the response variable in the study. In addition, these variables are typically related to explanatory variables considered in the study. My favorite example of this, my statistics professor gave it to me, was if we're comparing sunglasses sales with shark attacks, and we say the more sunglasses you buy, the more likely you are to be bitten by a shark. Well, that's not valid in any way, right? And 2, what's the lurking variable there? Summertime. More people are buying sunglasses in summer, and the rate of shark attacks might be higher in the summer because more people are swimming at the beach. However, there's studies showing that, there's not really a lot of shark attacks as the media might have us think, but I digress. That's another topic. I just like to use that example as your kind of idea of what a lurking variable is. Okay, and students, myself included, tend to get this confused with a confounding variable, whereas a confounding variable is an explanatory variable that was considered in the study, whose effects cannot be distinguished from a second explanatory variable in the study. So you already accounted for it. So let's say let's kind of use that same example. We're looking at animal attacks in the summertime, and we have sharks, barracudas, and bears. Well, the confounding variables would be sharks and barracudas because maybe the victim didn't see what animal attacked them, okay? They said it was just a large fish with sharp teeth, right? Well, how do I determine what's a shark attack and a barracuda attack without doing further evidence to look into, okay? So that could be a confounding variable. So the main difference is lurking variable, you didn't account for it in your study. Confounding variable, you did account for it from your study. The same thing that goes along with those is you can't distinguish one from the other. Okay. And then a census is a list of all individuals in a population along with certain characteristics of each individual. So it's basically data on whole populations, which are very expensive and take up a lot of time. Those are going to be a lot of caveats as to why we do samples and statistics. Okay, so let's determine what is an observational study and what's a designed experiment within problems A and B. So letter A says Yoda takes data from the archives and compares it to the data in Jedi holocrons to see which information source has more valid information. So think of it this way, Yoda is not manipulating anything here. He's taking information from one source, taking information from another source, and then comparing them. So this would be the observational study. Okay, we know letter B is going to be a designed experiment, but let's discern why. So a sample of 504 Jedi on Ossus are split into 2 groups. born during the reign of the empire or born after the reign of the empire. They are given a force sensitivity test to see how well they can utilize the force. The performance of these two groups is then compared. Okay, we're controlling for variables such as when they were born. We're giving them a test and we're seeing what results from there. So that would be the designed experiment. Okay, so for 1.2, just be able to discern between an observational study and a designed experiment. All right, we're almost halfway done. 1.3, simple random sampling. We're going to define the following terms: random sampling and simple random sampling. So random sampling is the process of using chance to select individuals from a population to be included in the sample. So we're just saying, okay, I have this whole population. I'm just going to use chance to grab random people. And our first method of random sampling is simple random sampling, often abbreviated as SRS, which is a sample of size little n. So anytime we see that little n equals 25 or equals 100, equals 225, whatever the number is, we know that that's denoting this is a sample size. So sample size of little n from a population of size n, that's going to be our population size, is obtained through this sampling method if every possible sample of size n has an equally likely chance of occurring. So we can think of an attendance sheet list. So I have this list, right? And what I'm doing is everyone has an equal likely chance of being chosen. The population is 30 or so students. And I'm going to choose 5 random people, pick them. Now they're in my sample. That's what I'm going with, okay? So for all my visual people out there, here is what simple random sampling looks like. We have a population. It looks like of up to 9 people. Then we're just going to randomly choose 3 people to be in our sample. We got 9, 2, and 5. Okay. All right, so I'm going to read 17. Now you see the Excel logo. This is just going to be, we're only, in chapter 1, we're only doing one Excel function. If you're nervous about Excel, don't worry. We're going to build up that skill, okay? But what we're going to be doing in Excel today is going to be super simple. So number 17 says General Leia Organa wants to survey 5 of her rebel pilots following the Battle of Crete. From the 109 rebel pilots stationed on Agent Class right now, obtain an SRS of 5 rebel pilots for her to interview. Explain the steps you use to obtain your sample, or you can just show what you did on Excel. So I'm going to go ahead and flip over to Excel and show you how to do this. Okay, so I went ahead and copied and pasted the problem that we have here in Excel. So what we're going to do is obtain 5 random people, okay? And the first, but essentially what we're doing is coding people. So let's say, how many do we have? We have 109 rebel pilots. So we would line up the 109 rebel pilots and say, okay, you're number 1, you're number 2, you're number 3, all the way to your 109, okay? So everyone has an assigned number. And now we're going to pick 5 of these people. So here's what we're going to do. In cell A1, it's a coordinate system. So A goes down, letters go down, 1, 2, 3 numbers go horizontal. Okay, to start a function, we always type equals. So we're going to type the equal sign. And then RAND. We're going to choose this last option that says rand between. Now you'll see here in parentheses, it says bottom, top. It's saying what is the bottom number, what is the top number. So our bottom number, we always start at 1 because with these simple random samples, we have discrete values, okay? And no one is person number 0, okay? They're person number 1, so we always start at 1. Top is going to be our sample size, which is, in this case, 109, okay? Then we close our parenthesis, and we're going to get a random number between 1 and 109. And you're thinking, God, how tedious. I got to do that for 2, 3, 4, 5. You do not. So what we're going to do is take this little corner right here, and we're going to drag it all the way to 5. Okay. And you'll see we get 5 random numbers. Now, I'm sure this is going to happen to you. You can see here we have 61, 61, right? And you're thinking, oh my gosh, am I going to account for 61 twice? Nope. you just round up to the next whole number. So that person becomes 62, okay? And it might change these, but theoretically, you're just gonna keep everyone random. Now I always get the question, well, what if you get 109? Go down to 108. If you're looking at every contingency of what could possibly happen, if you already have 108, just go down to the next number. Just go to the next number that hasn't been accounted for, whether you have to round down or up. It's ethical. Okay, so that would be my 5 people that I would have. Okay, now the answers are going to vary. So if you're having some anxiety looking at this, going, "Oh my God, I didn't get the same numbers." Remember, it's random. Okay, so it's just going to be random 5 numbers. I don't believe you have to demonstrate this on your homework. You might in a project. So just know that skill for when that comes up. Okay. All right, let's jump back to the study guide. So you see I have answers will vary here in the study guide. And this is how I show my work. I just say rand between, open parenthesis 109, close it. And I write the 5 random numbers I got. Okay. So I'm going to leave 18 for you to do on your own. It's the same process. Deidre Miro is conducting an investigation of ferrex and wants to see how many imperial navigation units, INU, have been tampered with due to rebel activity. From the 200 INUs on ferrex, help her obtain an SRS of 10 INUs. Explain the steps used to obtain your sample. So rand between 1, 200, fill it out to 10. Okay, then you're going to have your 10 random numbers. Okay, so for 1.3, you should just be able to obtain a simple random sample. All right, 1.4, we're going to have other effective sampling methods. Now I'm going to give you the definition of these. I'll give you some slide examples. Then I'll show you some visuals to help solidify what it is we're learning. Clay? K? Not Clay. K. All right, so stratified sampling. This is obtained by separating the population into non-overlapping groups called strata. So in other words, these groups are based on demographics, age, gender identity, weight, height, socioeconomic status, things like that. And then obtaining a simple random sample or an SRS from each of those stratums. The individuals in the stratums should be homogeneous or similar in some way. Okay, so you could think of it too as like, I'm taking all Front Range Community College and I'm going to separate the whole population by major. Then I'm going to take simple random samples from each of those majors. Okay, that'd be stratified sampling. All right, systematic sampling is obtained by selecting every case. Oh, when I was a student, I'd be like, what does case mean? Okay. Another way you can think of that about that is by selecting every blank line individual. Okay, it's basically insert number here, obtained by selecting every third, every fourth, every seventh person from the population. The first individual selected corresponds to a random number between 1 and k. So let's say you want to choose every 5th person. So you're going to start off somewhere between 1 and 5. We'll just say 2, okay? Then we're going to go every 5th person from there. That's how you obtain your systematic sample until you have, let's say, 100 people or something. Okay, cluster sampling is obtained by selecting all individuals within a randomly selected collection of groups of individuals. Clusters are based on geographics. Myself, all students usually get confused on the difference between A and C, which is fine. So the similarity between A and C is we have a population and we're dividing into groups. Where they differ is stratified sampling. We're going to be taking simple random samples from each of those groups, okay? Cluster sampling, you're going to be taking whole groups to go. And stratified is based on on demographics. Cluster sampling is based on geographics. All right, and then convenient sampling is a sample in which the individuals are easily obtained and not based on randomness. So if you ever have friends who go, I'm doing a study and I posted the link on Facebook, can you answer it for my class? That's convenient sampling. Or oh, I need to give out a survey. I'm just going to stand outside this building and just the people that come, I'm just going to say, hey, you want to take a survey? That's convenient sampling. Okay, so let's look at some diagrams to kind of solidify our thinking with this. So here's stratified sampling. We have a population, right? Then we're going to split them into strata. Let's say, I hate to do this, but I'm just going to use this as a method. We're just going to split up into the binary gender identity, so male, female. Okay, let's just say we have a group of males, a group of females, and then we're going to take a simple random sample from the male category, simple random sample from the female category. Okay, then we take those two people from each of the groups and then go, okay, here we go. That's our sample. All right, systematic sampling. Like I said, we're going to start from somewhere between 1 and k. So you can see this says sample is every third person selected. So k is going to be 3. So somewhere between 1 and 3, it's obviously 2. So we're starting at 2. Then we're going to choose every third person from there. So number 5, number 8, number 11, and then that's our stratified sample. Now remember, stratified and cluster different because stratified, you're basing it on demographics, and cluster, you're basing it on geographics. Stratified, you're taking simple random samples from each of the groups. Cluster, you're going to be taking whole groups to go. So with cluster, we have our population. We split them up into groups based on their location within the population. So you can see it looks like based on their 6th area of the population. Then we choose whole groups to go. So it looks like we chose group 1 and group 5 to be our random clusters. Then we put those together and that's our sample. Okay. Then remember, convenient sampling, it doesn't even need a diagram. It's just a lazily obtained sample. All right, so let's determine based on some of these scenarios, which sampling method we're using. So on election day, a pollster positions herself outside the Senate building in Coruscant and asks the first 50 senators leaving the facility to complete a survey. Well, they're really not doing anything to account for randomness, nothing like that. She's outside the building going, here, take this survey, take this survey. It's going to be our convenience sampling. An imperial officer randomly selects 15 planets from a certain quadrant in the galaxy and surveys every outpost on these 15 planets to determine the level of rebel activity. Okay, you're thinking of the galaxy, split into fourths. They go here and says, okay, every planet here, we're surveying the outpost based on geographics. It was split into 4 groups or clusters. We took that whole group, so that's going to be our cluster sampling. 35 Padawans, 22 Jedi Knights, 35 Jedi Masters are randomly selected to participate from 574 Padawans, 462 Jedi Knights, and 532 Jedi Masters on the Jedi Temple on Coruscant. Well, we have our 3 groups based on larger group sizes, and it's based on demographics because it's your rank as a Jedi, so this would be considered our stratified sampling. And then first order officers pull aside every 40th troop transport passing through the Supremacy's hangar, starting with the 12th for an emissions test. So if they're doing every blank, remember every kth or every blank number, that's going to be your systematic sampling. I always like to think of systematic sampling as it's following a pattern, and patterns are part of a system. So systematic pattern sampling. Okay, so for 1.4, you should be able to obtain a stratified, systematic, and cluster sample and identify those convenient samples. Okay, 1.5, we're going to be dealing with the bias in sampling. So convenience is obviously going to have a lot of bias, right? Like, why are you not accounting for randomness and why are you just going here to administer your survey? So bias, just in general, if the result of the sample are not representative of the population, then the sample has this. So if I, let me think, bias would be, I'm a huge Star Wars fan. So if I find a way to incorporate Star Wars into any of my studies when they don't have anything to do with Star Wars, that would be me implementing bias. So we have 3 ways that bias seeps into our samples, or our studies, I should say. The first one is sampling bias. which is the technique used to obtain the individual in the sample tends to favor one part of the population over another. So, in other words, how you obtained your sample has bias in it, and one part of that sample is being favored versus what's actually being held true within the population. Okay, then we have the non-response bias, which exists when individuals selected to be in the sample who do not respond to the survey have different opinions than those who do. My favorite example, and I'm so mad that I lost this screenshot. Maybe someone can find it on Yelp. It was for the Old Chicago on 120th and Colorado Boulevard. But it was so funny. So one person gave that Old Chicago a 1 out of 5 stars because they said the service was terrible. It was super slow. We didn't get anything we asked for. Kyle sucks. I'm assuming that was the person who waited on them. And then right under that, there was a 5-star rating that said, this was the best experience we ever had. Kyle was just so amazing. And that's the non-response bias because you can see two ends of the spectrum, a 1-star and a 5-star. Someone had a terrible experience, someone had a really great experience, and they both talked about Kyle. Now, does that accurately represent Kyle? Maybe. That's the key word we're going to be talking about. It might be representing him, right? He might be really extreme on the ways that he weights. However, there's probably a lot of times Kyle has just been your average waiter, and someone's going, I'm not going to go write about, I had lunch with my family and then we went and did something. I'm not going to get on Yelp and be like, it was the most mediocre average experience I ever had, right? So we can always think of non-response bias as when people want to share their opinions on extremes, they most likely will. Something to consider with Amazon reviews. However, when we get into like chapter 5 with law of large numbers, the larger amounts of people writing reviews, the more accurately it should represent. However, if you have 10 reviews on an item, let's say on Amazon, and there's a 1-star and a 5-star on each one, like it might be there might be some non-response bias in there. Okay. So then your response bias exists when the answers on a survey do not reflect the true feelings of the respondent. So let's say, like I said, okay, how did you find this video afterwards? It was a survey, and you had 3 options. Amazing, great, good. Now let's just say your experience watching this video, you didn't have a good experience watching it, and you're like, it wasn't for me, right? Well, I didn't give you the option to account for that on the survey. So now when I publish those results, I could go, look at what a great SI I am. I'm having these great videos that everyone just thinks is good, whereas the survey had bias in it because maybe I had an agenda about I don't want to receive any critical feedback to work on myself as an SI. Okay, so just look out for things like that. That's also when response bias can seep in. So let's determine which type of bias was used. Dex wants to survey his customers on their eating habits. He selects the first 60 customers who entered Dex's diner that morning. Think of it this way. They're entering in the morning. He's saying about their eating habits. Maybe a question's talking about, do you eat breakfast, right? So that would be the sampling bias. He's choosing people that eat breakfast that might not accurately represent the whole population, where people might not be eating breakfast. Okay. Suppose Captain Phasma is conducting a survey regarding the sleeping habits of first-order stormtroopers. From a list of registered stormtroopers, she obtains a simple random sample of 150 stormtroopers. One survey question is, how much sleep did you get? Well, how are you measuring sleep? Are you going to say, I got enough sleep? Or, oh, I got 8 hours of sleep? Or is they going to represent it in minutes, right? So we have response bias. It's going to be a poorly worded question. Then Mon Mothma wants to conduct a survey on how many senators approve of the new shipping laws for the Gormans as opposed to those who support it. She sends the survey to her constituency of 1,023 senators, and only 12 respond. Those who have strong opinions on it are going to respond. Those who don't will not. So that's going to be your non-response bias. Okay, so for again, numbers 23 through 31, those are the open-ended questions that I want you to think critically about. You can compare and contrast your answers on the answer guide for them. I would suggest doing those first. However, if you need to look at the answer guide first, that works too. So just know you can do this. I believe if you're watching this video, you are capable of answering these questions. Use everything that we answered within 1.5 to help you, and the textbook is also a great resource because there might be some things that could be further expanded on within just the 1.5 section. Don't read all of chapter 1, but just go to 1.5 and read that section to help you with those if you need. Skim. All right, so for 1.5, you should be able to explain the source of bias and sampling. Now our last section here is the design of experiments. Again, you are not going to be quizzed on this. You are not going to have homework on it. I just want you to know this because when we get into chapter 11, it is going to help solidify your understanding of that chapter. So we want to be able to define a matched pairs design, and we're going to create our own example. I'm going to use my own example. Feel free to use your own too, okay? So an experimental design in which the experimental units are paired up. The pairs are selected so that they relate some way, that is, the same person before and after a treatment, twin spouses, same geographical location, and so on. There are only 2 levels of measurement for this study. So how this looks is we're going to have, let's say we match Padawans according to gender and IQ. So then from there, what we're going to do is now that we have gender and IQ score, we're going to randomly assign a Padawan from each pair to a treatment, right? So 8 hours of sleep versus 6 hours of sleep. And then what we're going to do from there is administer treatment and exam to each matched pair. So group 1, you're going to get 8 hours of sleep, take an IQ test. Group 2, you're going to get 6 hours of sleep, take an IQ test. And then from there, we're going to take those results and then for each of the matched pair, compute the difference in scores on the exam. You know, group 2, who got 6 hours of sleep, did significantly worse than group 1, who got 8 hours of sleep on an IQ test. Therefore, if you're going to take an IQ test, make sure you get at least 8 hours of sleep for best results. All right, design of experiment. Define a completely randomized design and create your own example. So completely randomized design. This design is one in which each experiment unit is randomly assigned to a treatment. So let's say we have a population where we have random assignment of plants to a treatment. So what we're going to do is we're going to have group 1 receives 20 plants, so does group 2, and so does group 3. Okay, they all receive 20 plants. Well, group 1 is going to have treatment A, which is no fertilizer to those plants. Group 2 is going to have treatment B, which is only 2 teaspoons of fertilizer to those plants. And then group 3 is going to be treatment C, which is going to receive 4 teaspoons for those of fertilizer for those plants. Okay, then we're going to take all of those results and we're going to go ahead and compare the yield, which is fancy terminology for compare the results. Okay, so that's going to be random design. All right, so you're done with chapter 1. Yay. So for 1.6, you should be able to identify the matched pairs design and identify completely randomized design. Here's the chapter 1 summary. Feel free to pause the video and read it. You can read it on your study guide as well. Okay, but this is essentially what all of chapter 1 led up to and what it's about. Then we're going to have this thing called a know, want to learn, and learn. Before you start filling it out, do not fill it out. This is an example. What I want you to do is for all those, for 1.1, for 1.2, for 1.5, all of those, okay? I want you to look through those and first write down in the know column everything that you know, that you're like, I got that. I know what a parameter statistic is. I know what stratified sampling and systematic cluster is, okay? So that'd be your know column. So like for me, I could write, okay, I can define statistics and statistical thinking. I know what those two are. However, in the want to learn column, this is where you feel you need more work on, okay? So I might feel I need to obtain a stratified systematic and cluster sample. I need to learn more of that, okay? Now you know when you go to study, okay, what do I have to know for number 1? Okay, I'm going to study stratified systematic and cluster sampling. And your goal is you want to get it over to the learned column. So let's say, okay, I spent an hour studying it. I did flashcards, took a break, did another hour. I did the flashcards, no problem. I know what that is. Now you can move that want to learn thing over to your learn and say, I learned how to obtain a stratified systematic and cluster sample. And your goal is for each chapter to move all those want to learns over to the learn by asking me for help, asking a professor for help, doing your homework, studying any resource imaginable. Okay. We're going to have that for each chapter, just introducing it here. I hope you found this video helpful. I'm sorry it's long. Thank you for sticking along with it. It's going to be a great resource for you. The answer guide is posted as well. If you have any questions, please shoot me a text or email and I'd be happy to clarify anything. And until then, I'll see you in sessions and other videos.